Alright, grade 11s, what we're going to be looking at today is a rule called the chain rule. And I thought I'd start with something that looks like this first. X take 2 all squared. Now when we're finding our derivative of that, what you know now from before is that y is going to be x squared minus 4x plus 4. And so your derivative is going to be 2x take 4. And we could factorize that and it would look like this. 2 times x take 2. Now, can you see a relationship here? Notice the x take 2 doesn't change and our power has come down and our power is reduced by 1. So that's kind of a quick overview of how the chain rule works. We're going to do what we call the long chain rule first. So this is going to be the whole theory behind it, and then we'll show you the quick chain rule. Okay, so we use the chain rule when we have an expression that has the variable we're interested in, okay, inside the brackets, and it is raised to a power. So we say it's our inside function and our outside function. Now notice our variable is x and our equation is y equals 3 minus 3x take 2 to the power of all to the power of 3. So we're looking for dy by dx, the rate of change of y with respect to x. And the way we find that may seem like a little bit of a long way around, but those of you doing specialist will be happy with this because it'll help you with your related rates. So we're going to say, using the chain rule, we always say which rule we're using, and we're going to let u equal 3x take 2, so equal to that inside function. Okay, so therefore my y is now going to be u cubed, and I can find my derivative of y with respect to u, right? So dy by du is just going to be 3u squared, okay? But we know that u is equal to 3x take 2, right? So therefore, dy by du is actually equal to 3 times 3x take 2 all squared, okay? But that is still not yet dy by dx, okay? But the thing that I've got that has got an x in it is actually my u, okay? So I've got that u is equal to 3x take 2, and du by dx is just going to be 3. Now, the interesting thing about the way that these derivatives work is I can have that dy by dx is equal to dy by du multiplied by du by dx. Now, remember I told you that these things are not fractions and they don't cancel out like fractions and they do not work at all like fractions. Except that when you multiply two derivatives, if you have got the du and the du, one in the numerator and one in the denominator, they act as though they cancel out. Alright, so that means that I would then be able to multiply my dy by du times my du by dx, and I will get my derivative of y with respect to x. So that's going to be 3 times 3x take 2 all squared multiplied by that 3, so it's going to be 9 times 3x take 2 all squared. Let's try another one. Don't get stressed out about it, okay? So before we start with this, let's rewrite this equation with a in exponential notation with a power rather than with a square root. So we've got y equals 2x squared take 3x to the power of negative a half. Notice I have a function inside of my brackets that has got the variable x in it, and it is raised to a power. I'm looking for dy by dx, and I'm going to use my chain rule. So using the chain rule, I'm going to let u equal my inside function, so 2x squared take 3x. And so my du by dx is going to be 4x take 3. And I know that y is now equal to u to the power of negative half. So dy by du is just going to be negative a half u to the negative 3 over 2. Remember, I subtract 1 from my power. And I know that u is equal to 2x squared take 3x. So therefore dy by du is going to just be negative a half 2x squared minus 3x to the negative 3 on 2. But I'm looking for dy by dx, not dy by du or du by dx. So I'm looking for dy by dx is equal to dy by du multiplied by du by dx. And I know I've done them correctly when I have my one du in my numerator, the other one in my denominator. So I then have negative a half 2x squared take 3x to the negative 3 on 2 multiplied by 4x take 3. Alright, now I just need to simplify it, make it pretty, and get it into the same format that it was given to me in. Okay, multiplication is horrible. So let's have a look. We want to have, I'm going to take this back down under my numerator, under my vinculum. So I'm going to have negative 4x take 3 over 2 2x squared take 3x to the 3 on 2. And I don't like a negative outside of my brackets, so I'm going to take it as 3 take 4x over 2, and we'll turn that back into a square root, so it will be 2x squared take 3x cubed square rooted.